Are there urine jokes? I still hope you have the urine jokes. That's what kept me going.
Oh, like think of all the potential from what you can do. I didn't know we were going there today, Jess.
You're hearing Jessica Ray and William Tarpeh reminisce about their time working at UC Berkeley. They're both environmental engineers who specialize in water treatment and wastewater. For Will, that wastewater happens to be urine. We'll hear more about that later. I'm Carrie Jansen.
And I'm Atabey Rodriguez Benitez.
On this episode of Stereochemistry, we'll hear Will and Jess talk about how they thrive as assistant professors.
We'll also explore the science of clean water and the visions Jess and Will have for a more sustainable future.
For these two engineers, that means much more than just developing green technologies. They want to make sure everyone has access to clean water and sanitation. Jess and Will discussed those goals and more in a recent chat with C&EN reporter Katherine Bourzac. Welcome to the show, Katie.
Hi, thanks for having me on the podcast.
Well, I'm excited to hear more from Jess and Will. Katie and Atabey, I'll let the two of you take it away.
Thanks, Carrie. So, Katie, I was really interested to hear more from these two about how they are navigating life as new professors. They both started their own research labs within the last few years, right?
Yeah, that's right. Jess's lab is at the University of Washington in Seattle. Will is at Stanford University. Now that they're both assistant professors, they're helping each other figure out how to thrive in this relatively new role. As Will noted, being a new professor can result in some tricky situations.
Okay, assistant professors, we get a lot of advice, and that's a great thing from mentors. And sometimes, honestly, you get conflicting advice, and you're like, okay, how do I navigate these two pieces of completely diametrically opposed advice?
I can sure relate to that. I had two professors as my main advisors when I was in grad school. And let me tell you, it was an adventure. Figuring out how to navigate all voices and opinions took a lot of communication and patience. Jess and Will told us that a big part of how they deal with conflicting advice and other challenges is by supporting each other. They are both part of multiple support networks, mostly online over the past few years due to the pandemic. They told us they meet regularly on Zoom with a group of other Black assistant professors to work on grants and papers they're writing, and they give each other advice.
Yeah, it's a great space. I think what I also benefit from is the peer mentoring, because we're all at slightly different stages. We're all, assistant professors, but all at slightly different stages. So I get a lot of great info about issues that I'm having as an assistant professor. And then we also give back to the newer recruits that join the writing group as well. So it's been really nice.
Yeah, share proposal drafts, edit each other's work as needed, that type of stuff. Also troubleshoot, like, how do I talk to my department about this? Or how do I work through this with a student? That type of stuff.
Having the writing group opens the door to other conversations and other forms of connection.
During the pandemic, as we continued our writing time, we were, in addition to providing peer mentoring, just talking about frustrations that we have observed as Black faculty in our various departments. Usually we're the only Black faculty within our department, sometimes one of maybe two or three in the whole College of Engineering or School of Engineering.
So we have it started out as just an email thread, but there are 15 or 20 of us. And that in and of itself is very encouraging as Black faculty members to say, oh, wow, there's a lot of people replying to this email, getting added. Everyone is just adding people. And it's like, if you asked me how many Black faculty members are there in my field, I would have underestimated. And so that in and of itself is efficacy building, helps increase the awareness. There's also kind of unique needs that Black junior faculty may have in addition to those of every junior faculty member. And also that means that helping and building an environment in which Black junior faculty can thrive, of course, has spillover effects. If we're doing things like making evaluation metrics clear, or if we're doing things like establishing mentoring committees, everyone benefits from that.
And having a group of peers where you can bring your whole self to being a scientist can also mitigate the effect of stereotypes. We'll talk about how stereotypes can mess with your head.
The idea being, if you're aware that there's a stereotype in some setting where you are, it adds extra mental load and it may affect your performance in that setting, right? Whether it's being a Black student in a math class or taking the SAT, and you're made aware when you fill out the Black African-American bubble that, oh, there's a stereotype that Black people aren't good at math, that might affect your performance.
And for Will, support from peers and senior mentors can deflate the power of stereotypes. Jess added that the role models are also important too, especially for Black students.
If you talk to most graduate students, for example, who are Black and interested in pursuing, PhD research or becoming faculty, something that echoes in a lot of their comments is the ability to see faculty that look like them, to be represented in their future department, to see someone that looks like them.
Yeah, finding a community of people with similar background is really how I got to grad school. Just having a space where I can be my authentic self. So that makes me curious. How did Jess and Will meet? Will was a grad student, right?
Yeah, that's right. Will was a grad student at UC Berkeley, and Jess was doing a postdoc. Let's hear the story.
Yeah, in 2015, Jess just walked into the Berkeley Water Center and walked right by my desk because I had the honor of having the front desk in the whole place right next to the locked door, which meant I got a lot of exercise jumping up and down when people would knock. And Jess just walked by and I was like, oh, who's that? And so then we met probably later that week. We weren't in the same research group, but we were in closely tied research groups. We all shared lab space.
When Will was a PhD student, he was conducting research on urine source separation, which you should also ask him about. It's really interesting. And for his urine source separation research, he, of course, needs urine to do the experiments. And I was a very proud donor to Will's PhD research.
Thank you.
When you get your multi-million-dollar award, I want acknowledgement for my contribution. I mean, that is one vivid memory I have of our time at Berkeley. Like, oh, Will's collecting urine again. Guess it's time.
And that's because you're trying to collect some nitrogen or...
Okay, good question, Katie. Why are we doing this time? Yeah, so we were, at the time when I was a PhD student, we were developing some novel technologies to selectively recover nitrogen as ammonia from urine. Why urine? Because urine is just 1% of wastewater volume, but contains a large portion, around 80% of the nitrogen that we excrete.
Will, is it challenging for you to solicit samples from people, or is your work still involved in this?
It does, but now we have a whole operation. It's amazing.
Will's lab has what they call a dispensing room.
The crown jewel of our lab.
Basically, it's a few lab-grade urinals that capture people's pee. There's also a setup to discreetly urinate into a sterile cup. Will has decorated the area with humorous and encouraging slogans to capture the interest of his donors. You heard some examples of those at the beginning of the episode.
Like, you're in luck. Today's your day to donate. These are the things I would put above the collection containers just to catch people's eye.
Okay, but why all this talk about urine? Katie, tell us a little bit more about Jess and Will's research.
Right. So, as we mentioned earlier, Jess and Will are both environmental engineers who work on water. Jess uses her knowledge of chemical engineering and nanotechnology to make new materials for water treatment. Her goal is to make equal access to clean water a reality. So she's developing low-cost systems for removing toxic chemicals from our water. And many of Will's projects are about sanitation and how to treat wastewater. That means developing low-cost systems that clean up waste for schools around the world. He's also interested in mining valuable chemicals from our urine. Our pee has ammonia in it that Will thinks we could capture and use as a low-cost fertilizer.
And Will's work goes way beyond just nitrogen. His vision is to mine different types of wastewater for a range of valuable materials.
Humans, we generate teraliters of wastewater every day. It's kind of a huge mind-boggling number, and that's even hard to wrap your mind around, but it's a lot of wastewater. We're extracting and consuming materials from the environment and then just emitting them into the environment in different forms. And that, by definition, is an unsustainable system.
Will wants to mine nitrogen, phosphorus, and even carbon that could be used for fuels. Mining chemicals from wastewater in the process of cleaning it up has a double benefit. In the end, you get clean water and valuable chemicals.
There's literally so many mineable products in wastewater that a lot of us will be in business for decades because there's still more you can extract from wastewater, and it solves two problems at once, right?
And Jess is also making good use out of something that usually gets thrown away. She's not working with urine, but she is turning trash into treasure.
So one of the materials that our group is developing is taking used coffee grounds that we're actually getting from the University of Washington catering services after their events. And then we burn those in the lab and create an activated carbon adsorbent that we're then testing in the lab to remove stormwater contaminants. So It's a really nice puzzle of, the two things you think about when you think of Seattle. You think of the coffee capital of the world, and you think of all the rain that we get. So it's a nice marriage of the two. And it's another example of how we can upcycle what otherwise would have been just a composted waste, and then using that for an environmental good.
Jess's materials can filter out contaminants that are harmful to people and to animals. For example, her team is targeting a class of contaminants that we often refer to as PFAS. That stands for a kind of intimidating chemical name that I will say once and never again in this episode. They are per- and polyfluoroalkylated substances.
That's quite a mouthful. But PFAS are pretty common, right?
Yeah, that's right. These chemicals are in a surprising number of products you probably have in your home right now, like nonstick pans and waterproof coatings on takeout food packaging. They're also used as fire retardants. Unfortunately, some kinds of PFAS are toxic. They've been linked to immune system problems, cancer, and other health issues.
And these compounds earned the nickname forever chemicals because they are super stable. And that's a good thing if they are being used on something like a nonstick pan. But it also means they persist in the environment for a really long time.
Because of all of these uses and developments and applications, there are now over 5,000 different types of PFAS within the class of compounds. And this is a problem because of the way they're designed, right? So we need to come up with more creative and innovative approaches to first remove those compounds from water and then ultimately degrade them so that they no longer pose a risk to human and environmental health.
With Will trying to mine wastewater for resources and Jess making used coffee grounds into water filters, it sounds like they're focused on recycling and sustainability.
Yeah, they're both passionate about chemical solutions that eliminate waste rather than generating more of it. And that ultimate goal has naturally led Will beyond water to other kinds of waste recovery. For example, here is how Will thinks about a topic his lab has started to investigate recently: engineering new polymers.
When we think about just the kind of heaps of plastic, when you take out your recycling bin every week and you think about you have filled this bin that is several gallons large, and you look at all the houses on your street or all the apartments in your complex, you start to get a sense of the scale of that, right? And it kind of makes you wonder, when people were designing these plastics in the 20th century in particular, it's like, were they thinking of the scale of what happens during disposal? And I think they were thinking of the scale in terms of getting plastics in people's hands and making these convenient, right? It's not like, sometimes I try to remind my students, it's not like people who came up with these things were like evil people, right? It's just like the world was different, constraints were different, incentives were different, right? It was like about democratizing things and getting lots of people access to things.
But that mindset doesn't take into account what happens when you throw plastic away. Will told us he's really excited about the opportunity to rethink how products are designed, down to the base polymers that are used to make them. That way they can be safer to dispose of once they've reached the end of their useful life.
Right. So now that we think about disposal a lot, it means that if we think about designing with the end of life in mind at the beginning, it's going to change which polymers or which formulations we think are best suited for different applications, right? And so it takes this whole reframing of one's mind to really change and forecast for decades. And that can be paralyzing at times, but it also gives you a felt sense of opportunity.
So that was really big picture. We've been talking about how to make a circular economy where water and polymers and other precious resources get reused, not wasted. Next, we'll zoom in a little on how Jess and Will want to accomplish this. Knowing that these two are friends, I wanted to know if they had any questions for each other. We'll hear more about that after a quick break.
Hi everyone, Gina Vitale here. I'm an assistant editor at C&EN, and I'm here to remind you about a great way to stay up to date with the latest news from the world of chemistry and chemical engineering, our weekly newsletter. The newsletter delivers the best of C&EN to your inbox every week. You'll get the most important research findings, the emerging trends you need to know to get ahead, plus the latest jobs and career insights, and also some really cool extra content, like periodic graphics in collaboration with the science illustration website Compound Interest, or Chemistry in Pictures, which showcases the beauty of the central science. You can sign up for our newsletter at bit.ly/chemnewsletter. Just point us to your inbox and we'll take it from there. Again, that link is bit.ly/chemnewsletter. We'll also include that link in this episode's description. And now, back to the show.
So, before the break, we heard about Jess and Will's focus on sustainability. In the second half of the show, we'll hear more about how they are putting this green vision into action.
That's right. When I asked them if they had any questions for each other, they both wanted to pick each other's brains about opportunities for more sustainable water systems. And being engineers, they got right to the nitty-gritty of it. So I had asked you guys if you wanted to ask each other any questions in this forum. I'll give you some time to do that.
I have a question for Will.
That was fast. Okay.
So my question is, what, in your opinion, is the biggest opportunity in source separations or electrochemical separations?
Ooh, in electrochemical separations, biggest opportunity. How much time you got, Jess?
I figured you might have something to say.
I think I'll interpret the question, though, to think about the kind of fundamental advances that electrochemistry could afford. And I think one that I've been thinking a lot about, and many people have been as well, is kind of combining electrochemical separations with electrochemically driven reactions. The idea being that co-designing catalysis and separations using electricity as a driving force for both can really change and enable, maybe more importantly, it can enable completely new applications.
It seems Will is always thinking about new ways to turn wastewater into treasure. Jess's answer to Will's question hits a little closer to home. She pointed out a surprising feature of the water we use.
I think I would throw it back at you, Jess. I want to hear more about stormwater. I feel like I haven't heard you talk about stormwater for a long time. Maybe it's a climate change question, but what do you think are the opportunities we're missing in stormwater treatment, the overlooked things?
Something I talk about is how, for example, all of the water in our toilets is drinking water quality, and the water that we use to water our lawns in front of our homes and at parks and playgrounds, that's all, drinking water quality water that we have treated to the highest extent possible. And if we can think more creatively about other water sources to use to save drinking water for drinking and not to use for these existing applications, then we can really think more creatively about how we manage our existing stormwater, because right now we don't. In most newer US cities, when it rains, the stormwater goes down a drain and then directly into the nearby lake or river.
That's pretty wild to think about. Does the water we use to flush our toilets really need to be as pure as the water coming out of the kitchen tap?
If you're fortunate enough to have a reliable, clean water supply, it can be easy to take that for granted. Just turn on the tap or the hose and it's there. But that's not the case for a lot of people. There are many reasons why someone might not have access to a safe water supply, including rising costs, inadequate infrastructure, contamination in water systems, or environmental reasons. I grew up in Puerto Rico, where we sometimes have droughts in the summer. And during one of those droughts, when I was in college, 24 of us in a dorm had to ration a water drum. It was a challenge, to say the least.
I can imagine. These kinds of experiences can really affect your point of view. I live in drought-prone California, and I grew up here. Growing up, our family was on well water. My parents were always reminding my brother and me to turn off the tap, and we had to take short showers. Now that California is in another historic drought, I think about water conservation every day. Climate change is making droughts more frequent and more severe. That's why scientists like Jess and Will are working on ways to conserve water as much as possible, not just in the lab, but at home too. So for you guys thinking about water all day, every day, does that influence, what you do in your home? Do you do anything to save water?
I will say at times, especially with respect to the vast amount of contaminants present in water sources and understanding the level of efficacy of existing water and wastewater treatment plants, it can be really concerning to know what's there and what's not being done. I do like to inform, friends and loved ones about perhaps changing some practices that will help mitigate what I already know to be a significant problem. So, we all have people in our lives like that. And sometimes it can be really great and really inspiring. And sometimes it can be really annoying. So walking that fine line of here's what I know that you might be interested in is difficult to balance sometimes. But yes, absolutely. I try to save water as much as I can.
Definitely. I think Jess has covered it in terms of water. I feel like in my family and circles of friends, I am not the environmentalist, but I certainly am on that side of the spectrum. So we compost at home because I like doing that. And I, like many people, have a pandemic garden, of which I'm very proud. We compost. I'm trying to convince my wife to let us install a source separating toilet. That's sort of like a long game. Jess knows my wife, so she's like, it's a step-by-step thing, but like we're making progress, I think we can confidently say.
Those are some good thoughts on what we can do to be green at home and conserve water. But I also wanted to know what these engineers see as the future of water on a larger scale. Our individual decisions are important, but as we all know, it's about a lot more than that. Jess said her number one concern is not a purely scientific one. She wants to make sure all people have equal access to clean water.
I think first is equitable access to clean drinking water throughout the US, and making sure that we don't continue propagating existing disparities with respect to not only clean access to water, but just environmental pollution in general. Making sure that we protect the communities that are most vulnerable. One of my first projects was building or designing iron oxide nanoparticles to treat arsenic and water. And so when I was doing some research about arsenic contamination, I found a lot of information about where there are excessive loads of arsenic in groundwater and drinking water sources, and those communities impacted.
One of the places with high levels of arsenic in the drinking water is Bangladesh. And Jess's group is doing some work there, using locally available materials to filter arsenic from the water. But arsenic is a problem in the US too. I actually wrote a story about this contamination for C&EN about 2 years ago. Navajo Nation land is contaminated with arsenic and other heavy metals. Scientists have found that about 30% of people living there have no access to clean drinking water. Jess and Will both spoke about how equitable access to resources motivates their work.
The way I think about it is I'm very motivated by science, and how I got into the field had a lot to do with just thinking about the different impacts that where you're born in every sense of where and to whom and all of these things, what your community looks like, what access your community has to basic resources can affect so many things, right? And so for me, I've always been interested in thinking about how do we make our very cool technologies work out in all types of settings and address unique problems and unique opportunities also. Sometimes we forget about the opportunities in resource constrained or low income communities that are posed by these different constraints.
Will pointed out that sometimes engineering problems in different parts of the world can lead to different kinds of solutions based on the constraints you encounter. Some of his work has involved sanitation systems in sub-Saharan Africa, which operate with different constraints than what he might typically encounter with projects in the US.
If there's sanitation systems at school, girls are more likely to stay in school. And so for me and my work, what that has meant is a lot of work in sub-Saharan Africa focused on increasing people's access to sanitation to decrease diarrheal disease, increase the number of girls going to school, these types of things. And so those have been big motivators for my work, because sanitation is so fundamental to so many different parts of life. And so for me, what that has meant is that as we design technologies, we've piloted them in Kenya, we do some work in Senegal as well.
Will said working in places where solar panels are the main source of power provides opportunities that might not exist in other places.
Sometimes there's a dichotomy between like tech savvy techniques, or like if it's fancy and has a bunch of widgets, it should be used in the US. If it's simple and low cost, it should be used abroad, especially in sub-Saharan Africa. And there are ways to subvert that dichotomy for sure, especially with things like solar panels, right? Solar panels and electricity means that we can run electrochemical techniques pretty easily.
Electricity from solar panels is perfect to use for the kinds of electrochemical reactions he uses for water treatment. And this power source opens up new possibilities. After listening to Jess and Will, I can't help but think more deeply about things a lot of us take for granted. Maybe this deeply established water treatment system we have in the US needs to be revamped. Does it make sense that the water that fills a toilet tank is clean enough to drink? Should we be thinking more about the potential in the water we flush down the toilet?
Those pee jokes do stick with you, don't they? I guess you're in luck.
For sure. And I'll stick with the short showers too. Remember at the beginning of the episode when Will said he gets a lot of advice? To wrap up our conversation, we offered Jess and Will the opportunity to dole out some advice of their own. And they both had very practical answers.
I think the biggest piece of advice that I got, and the biggest piece of advice that I can give to new PIs, is time management. So blocking that time for me, including our writing meetings, right? Like blocking that time to do work that absolutely has to get done. It's critical as an assistant professor to block time for writing, to write proposals, to get more money, to continue, right, the work that we're doing. So that's been huge for me. And I tell everyone that you do worry about how much time you have, how much money you have as an assistant professor, and all of your many interests. And you have to be really careful about what you say yes to, what hole you want to, decide to jump down and pursue further versus staying more close to home.
My short advice would be, I think it's just sort of identify your strengths and lean into them. I think on the spectrum of scientists, maybe I'm more intuitive. And so I just allow myself space to make a game time decision sometimes, whether it's how to phrase this in a paper, or whether we should go for this proposal or that, or it's just a lot of decisions one has to make. I don't like making decisions about equipment because I feel like I'll always have buyer's remorse. So I very soon got my students in on the let's compare quotes together and figure things out, because I just got really tired of, for every piece of equipment, it was 30 more questions. And I was like, I don't know. I just want a pH meter. Please, just a pH meter. And so that decision fatigue, I think, can be real. And so try to identify your strength or way of doing things and lean into it, and then kind of buttress whatever weaknesses you have or the parts of your job that are most taxing on you.
This episode was written by Katherine Bourzac and produced by Carrie Jensen. Story editing by Michael Torres and Amanda Jarnell. Production assistant by Gina Vitali. The music in this episode was Different Kind of Love, instrumental version. Boom, instrumental version. And Something New, instrumental version, by Anthony Lozaro. The promo music was Plain Loafer by Kevin MacLeod. Stereochemistry is the official podcast of Chemical and Engineering News. C&EN is an independent news outlet published by the American Chemical Society. Thanks for listening!